Good afternoon. My name is Ellery Crane. This is my colleague, Jack Mazurkiewicz, and we're going to be talking to you today this afternoon about our experience building an enterprise CRM using primarily Grails and Spring integration. Let me kick this off. To give you an overview of what we'll be talking about today, after we explain who we are and who we work for, we'll go into exactly what a CRM is briefly for people who aren't familiar with that type of software, and then explain the technical challenges that we had when we began the design of our CRM system, with a lead into an explanation for why we chose the technologies we did, how the end design turned out, and why these were the right choices for our problems. The second half of the talk, we're actually going to dive into two specific pieces of functionality that we built with Grails and Spring integration to meet our needs as part of a CRM, with an explanation and technical overview of how we were able to use the tools in these technologies to build these specific functions. Finally, we'll wrap up by explaining some of the lessons we've learned with using Grails, Spring integration over the course of our project, and then we have set aside time for questions at the end. So if during the talk you have any questions related to the clarity if something's confusing, please speak up immediately. But if it's something you just want to dive into or pick our brains about, please just hold off to the end, and we will make sure we have time to get to that. So who are we? Well, as I mentioned, my name is Ellery Crane. I've been a web application developer professionally for about 6 years now. My background is primarily in Java and Spring, though I've done some extensive work in PHP as well. And before that, I've also done quite a lot of research in an academic setting in the area of evolutionary computation, if that's something that any of you have any familiarity or interest in. I've also been primarily a Grails developer for the last 3 years, and in that time frame I have had to work the opportunity to work on 3 major projects, including the one you're about to hear about, with using primarily Grails as the technology.
Thanks, Ellery. Hi, everyone. As Ellery mentioned, my name is Jack. I've been writing software since about 1999. My original background is in trading systems, writing online trading systems for registered reps and broker-dealers, where I touched the Spring stack first in 2007, and then I started working with Grails in about 2010. And about 3 years ago, I actually shifted gears and moved out of the financial world and decided to cast my lot in with with a company that built software for auto dealerships, and it's been a fun 3 years so far. By the way, in case we failed to mention it, that company is called DealerComm. You may actually have recognized us or heard about DealerComm in the recent past if you're a follower of Reddit, because we built a software portal to connect our East and West Coast. And if you followed any of that conversation, you'll remember that it went downhill rather quickly, but it was a fun thing. So, who is Dealer.com? Well, we make digital marketing solutions for the auto industry. We've been around for a good long while now, and we have 2 offices, one in Vermont, one in California. We've got a bunch of employees, and more importantly, we've got over 10,000 customers, ranging from some of the big guys, the car manufacturers themselves, large dealer groups, and your just local franchise and independent dealerships. And what we do for those customers of ours is basically a wide range of services that basically manages their digital presence. So you have the slide deck. You can take a look at all this. We do loyalty management, marketing, inventory, and most recently we've gotten into customer management and CRM, which is what we'll be talking about now. So our engineering team is about 150 people. We've been growing a lot. When I joined, I think the engineering team could fit around a single table, and that was 3 years ago. So we're growing, and we solve a lot of fun problems because of the number of customers we have and what we're trying to provide for them. And we're always exploring new technologies to try and solve those problems most effectively. So for those of you who don't know what a CRM is, which I imagine is at least some of you, it's a customer relationship management system. And when I say customer in this sense, I'm not talking about our customers, the dealers. I'm talking about the car buyers themselves, who are the dealers' customers. So the CRM software helps dealers find their customers. It helps them work with them and develop the relationships that they need to so that they can retain their customers, and it helps them win back their old customers. It's basically a software platform that helps them gain insight into who the car buyers are, what the car buyers' needs are, so that they can decide who to call and when. They can use features such as advanced search and customer aggregation to help inform their marketing decisions and sell more effectively. And at the highest level, the executives can actually look at analytics and reports and analyze trends in customers' needs so that they can influence the overall decision-making strategies in their business and help grow their dealership business to sell more cars. So the funny thing about the CRM software is that if any of you have bought a car, and I imagine that's most of you in here, we tend to think of buying a car as a long, drawn-out purchase, right, where we actually do some research ahead of time, and we're thinking there's a big decision process that happens. Well, the dealership itself, when you arrive at the dealership, that's a point of sale. It's like going to a Best Buy or an Apple store or wherever a point of sale that you can imagine, and basically the dealership wants to sell you a car on that day, then and there, and they want you to walk off. So with the CRM software, we're able to give the dealers insight higher up in the sales funnel so that they can actually work with the customers and help that decision-making process and help match customers to exactly what it is that they need and more effectively sell them these cars, and everybody is a little bit happier when we can tailor to them that way. So that's basically a high-level overview. Let me just tab over here and show you a little bit of what I'm talking about, which is just a quick demo of what it is that we ended up with. So right here I'm showing you a dashboard that a sales manager would be looking at. And all these things in red that you see are internet leads that come in. So when I talk about leads in general, a lead is something that represents customer interest, and in this case, it's customers' interest to buy a car. So we tend to get a lot of leads that come in as either forms submitted on a web page at the dealership's website or through phone calls. But either way, so the manager's sitting on here. He's looking at all the stuff that's happening at the dealership, and then he can see some details about this. He can choose to go to this contact details page, or he can also look at what his sales agents are doing, because the sales agents themselves have a different view into this, and they are basically presented with lists of tasks, and this is the who do I call and when do I call them, so that they know exactly what they're going to be doing. And from here they can work the task by sending an email, or if they need more information to figure out what's going on, they can tab over, inspect the history of the contact and see what's going on and things like that. There are some other features, but it's basically a system where it helps the dealers work with their customers, and it helps them figure out how to make the sale, and all the other things that I said earlier. Anyway, so in building this system, we had some technical challenges that we actually had to overcome, and we had to think about these things in order to decide what are we going to build it on. So one of those challenges was scalability. So I mentioned earlier that we have 10,000 customers, and so we're building this system keeping in mind that we hope that every one of those customers wants to add the CRM to our offering with them, so that they can become our customers and have this better insight into what their customers are doing. So we had to contend with that. We also had some challenges in multi-tenancy, because so the data, the customer data, which is the car buyer data, is it needs to be constructed in such a way that we have a single view of a customer in the database, so that when we're doing reporting on it, or when the executives are looking at these customers, they see a single profile for a customer. We have to deduplicate things. However, not everyone in the system is able to see that same full profile, right? Because if you're in a dealership group and you have two different stores which may or may not be competing with one another, they have to have different views into what that customer is doing so that they can't basically steal from one another. And we had to contend with all this stuff, and we had some fun multi-tenancy problems to deal with. But basically, in effect, it turned out that we have a customer record that is in a single database, but we have to treat it as though it's in multiple databases at the same time. And of course, the users cut across the entire group hierarchy, so it can become, it compounds the challenge. The other thing we had to deal with was any sorts of customizations that the dealers might want in installing this system, because everyone likes to tailor things to fit their business needs, so we have to deal with branding, special rules and validations, permissions, and all things that you can think about that you might want to customize. Then there was the technical challenge of actually interfacing with other applications, right? Because if we're not integrating and interfacing with other systems, then your customer database is little better than a Rolodex, and you may as well keep it in a spreadsheet or something. So I showed you earlier all of these things. We're hanging out in that bottom corner over there, so internally we have to integrate with all these products internally so that we can actually have a platform and not just isolated systems working together. Externally, we have a lot of things that we have to deal with as well. So in addition to our own websites, our inventory systems, email systems, notifications, vehicle catalog data that we keep, we also have to take leads in from third parties. We have to contend with legacy CRM data that we install whenever the dealer signs on. We have to take data from car manufacturers, credit bureaus, dealer management systems that are installed at the dealerships, and we also integrate with phone call providers and call tracking providers and things of that nature. So another sort of piece that we had to deal with was that in a lot of web applications, you have a system where there are a few users, and those users log in, and they create a little bit of content, and then that content is consumed by further downstream by end users, right? But there's a little writing, and then everyone else is reading. Our system is exactly the opposite. So what we have are users, end users at the dealership, salespeople, managers, basically going in, working with all of this data, appending to customer records, creating activities, working tasks, submitting leads, doing all these things so that they can further work those contact records later. So everyone in the system is constantly appending and appending so that they can actually build this 360-degree profile that I was talking about earlier. On top of that, we have to make the data searchable whenever we can, because after all, the reason why you're putting the data into the system is so that you can get back at it afterwards. And we also have some fun complex event type scenarios where a lead can come in, tasks and notifications get generated off of that. There are certain life cycles that happen at the dealership that create more tasks and more data as a result of all this processing that's going on. And then we also have to ship all the data off to a data warehouse for reporting aggregation purposes. Finally, the biggest sort of problem that we had was we didn't want to make any decisions too early on, because we needed to build a system that could be suited to different dealerships' needs. And so one of the biggest challenges was to sort of do late binding on our decision making whenever we could, so that we can build a system that's configurable in most ways. And one of our bosses helpfully asked us, why don't we just make everything configurable? And so we did, or at least we tried to. And in trying to do that, we selected a couple of technologies that made it easier to do this. So that's some of the challenges. And Ellery is going to give us a little overview as to the actual design that we came up with and what we're dealing with.
Thank you, Jack. So that's the setup for what exactly we were facing when we sat down and we said, okay, how are we going to build this? Those challenges that Jack just went over touch sort of every aspect of the application, from front end to back end, configurability, scaling, search engine technology, everything. And so we realized very quickly that we weren't going to find anything to build CRM off of that would give us what we need for all of that out of the box. Instead, what we really wanted was something that gives us 80, 90% of the standard web application framework level features while allowing us to build out the specific pieces that we need to address those challenges. And so what we found is that by using Grails as our primary framework and then using Spring integration and other technologies, we were able to do just that. So this is the design that we settled upon, and this is what you just saw when Jack clicked through a bit of it a few moments ago. So at its core, CRM consists of two Grails applications. We have a UI application and a services application, both of which are largely stateless. There's some state preserved in the UI for user session information about authentication and a few pieces that we'll actually talk about later. But largely, they're stateless and thus can be horizontally scaled by simply spinning up new application instances on demand. They communicate with each other using a RESTful API with JSON as a primary data layer for communication. We use the Jackson JSON serialization library to turn our model objects to and from JSON to share them across the pipe. The UI application is what the users actually connect to when they are trying to view anything in the CRM and submit data to. But it doesn't handle any business logic. It's pure presentation and form submission, data entry, that sort of thing. All of the business logic lives in our services application, which is another Grails application, but it has no front-end technology. It's only for processing, for actually performing the interaction with the database, for doing asynchronous processing, third-party integration, everything. And it's consumable not just by our UI application, but as you see here, we knew we would have multiple consumers out of the gate. And the first one, of course, being a mobile application, which is actually still actively being worked on, as well as other DDC platform products that might need to tap into CRM the way that we needed to tap into them. Now, the services app also is, as I said, it's what connects to our database, which we are using MongoDB for. Our search engine is ElasticSearch, both communicating, we use the same serialization and domain model to persist to both of those technologies, which has been very useful. The other DealerComm platform offerings are something that also we connect to from the services application, primarily through messaging using RabbitMQ, which we've wired together using Spring AMQP and Spring integration, some of which we'll talk about later on in this talk. But then there's other more standard remote service calls happening there and as well. So that is the integration layer. Both of our Grails applications share some common functionality. As I mentioned, we're sharing our domain classes, our model objects, which are actually encapsulated in a standalone Grails plugin, it's installed in both applications, as well as a common plugin where there's other shared functionality. That model is also exposable as a standard Java library so that other consumers of CRM can actually just depend upon our model without any of the other dependencies and communicate, again, using our RESTful layer or other messaging systems with those model objects. And then finally, our UI application is part of our broader platform. And so we get a lot of things, including single sign-on and look and feel stuff that we saw briefly earlier out of a shared Grails plugin that all of our DDC platform applications use to instantly fit into that broader ecosphere that we talked about. So that's a very high-level overview of how CRM in its final state was put together. So with that in mind, why did we make those choices? What brought us there? And first of all, why Grails? Well, there are many, many reasons to use Grails, and I think there's plenty of other talks here that you can go to, which they'll talk to you about. But from our perspective, the fundamental choice that we had to make was made because Grails at its heart is really just core Spring. You can take away all of the fancy extra features it gives you. It is core Spring, but with some sensible defaults and a whole bunch of enhancements designed to optimizing developer productivity. You can get it up and running faster, less development effort, less boilerplate, and with all the power that goes along with just core Spring. Now this is important to us because we can also then add in other Spring products that we're very familiar with piecemeal, and we have done so, and in many cases found that using Grails instead of core Spring as our platform for the various applications it's actually been easier to integrate most Spring products than it would be if you were working in a standard Spring environment. And as I mentioned, this is important because at Dealer.com we are primarily a Java shop, and we have a lot of developers who have a lot of expertise with Spring products, and we wanted to make certain that when we were building out the CRM that we could capitalize on all of that. We could make use of all of the developer expertise in this area with these products, and we've been able to do so. But on top of that, as I mentioned, we weren't just looking for a framework. I mean, we could have just used Spring. That would have been fine, but we were looking for something that would allow us to extend the framework, to get us what we were after. And so Grails offers actually a terrific number of hooks to do exactly that. By using Groovy, you can make use of just Groovy language features that are designed with those sorts of goals in mind. It's very easy to make Groovy DSLs that support the framework level needs unique to the product. Using metaprogramming and AST transforms, you can do some very, very neat things to do things at a level which with a standard framework you'd have to really do in code and would not be as seamless and as easy to plug and play. By creating customized Grails artifacts, such as, for those who aren't familiar, Grails artifacts mean things like services, controllers, tag libraries, and so forth. You can build your own and use those to get some of the same features that as Grails developers you might be used to, but for your own domain-specific artifacts. The hooks that you're given via controller action filters, it seems like a very simple feature, but is actually a very, very powerful one when it comes to doing all sorts of framework level concerns such as profiling, logging, and then just putting in hooks around individual requests in a way that is much easier to reason about using the Grails controller action convention than in many other systems where you'd have to do a whole lot more inspection of what the request is actually doing before you could put in the appropriate logic. And then finally, the Grails plugin architecture you'll loudly hear trumpeted at this conference especially as being appealing because it gives you a lot of off-the-shelf functionality by just going out and finding a plugin that does it. And that can be true, but more importantly for our purpose is that if you actually use the plugin infrastructure to build your own plugins, you actually get access to Grails framework features that aren't actually normally exposed in the Grails application problem domain. So we will go into some of how we've done that later, but it's actually a very powerful tool with no desire to necessarily make a public plugin. You can just build a plugin. Like I mentioned, we have our whole platform encapsulated in a single Rails plugin and share amongst any number of applications. And so this was from a back end largely what what led us to think about Grails. From a front end, I will just say that all of the Grails features regarding front end designed tag libraries, templates, the layouts, everything we have found on numerous projects at this point to be by far the best in class framework for doing view level logic. And so by doing this, you can write view code in the same way that many of us who are more familiar with back-end code tend to do things by encapsulating and reusing functionality in ways that with a traditional view framework would be much more difficult to do. And we've built a lot of stuff into that unfortunately we're not going to, in the time we have available, dig into. But suffice it to say, it's allowed our UI developers the same type of power for building out framework level enhancements that we as back-end developers were looking for as well. Now, it should be mentioned that for those who are familiar with Grails, and if you heard Graham's talk last night, one of the killer features that Grails offers is GORM, the built-in object relational mapper and persistence layer. We are not using GORM. And this is something that a lot of people, when I've talked to them about this, have been very surprised about, because they think Grails, Gorm, wedded. You cannot use one without the other. So why would we do this? Well, Gorm is terrific. I love Gorm a lot, but it has some limitations. And first and foremost, at the time we started building CRM, we knew we were going to use MongoDB. And at the time, this is about 2 years ago, we started development. There was no official MongoDB Gorm integration. So right there, of course, it's sort of a strike against it. There were some other plugins out there that people had put together to start that process, but there wasn't anything we could just drop in. However, there is now a Gorm support. So why wouldn't we consider switching over to it? Well, there's still reasons. Even right now, if we were to start building CRM again, I do not believe Gorm would be the technology that we would use for our persistence layer. And that is, and we're going to get into a lot of the details about this very soon, so bear with me, but we need a lot for what the type of concerns we're dealing with. We need a lot of access to the persistence layer, a lot of control over every type of data that we're creating and every part of the platform. And Gorm is great for doing very simple operations, but when their operations are very complicated, I know from experience that it breaks down and makes it in times a lot harder to do what you're after. So for our enterprise concerns, we really needed a lot more fine-grained control over the persistence tier. So Love Gorm was not the tool for this job. However, the important takeaway is that despite not using Gorm, Grails has been absolutely the right choice for the framework level technology for this product. It has given us everything we've needed and more. Without using Gorm, we were able to put in our own data layer, which we will get into, without any issues whatsoever. We were able to inject it, and just making use of the Grails conveniences of basically just being core Spring, wiring all of that together, completely seamless, very easy. Don't have Gorm dynamic, we weren't able to use Gorm dynamic finders. That's fine. We were able to use Spring data and use its query DSL alongside all of the other standard Grails services, tag libraries, and so forth that we were using. And then as a segue into the next section, we were able to actually tie all of that together very easily using Spring integration.
Right, so why do we use Spring integration in the first place? Well, I mentioned earlier that we had a lot of integration points, both internal and external. And for the internal integration points, we largely have a good handle on how to talk in between services inside of our own platform. But when it comes to external integration, every external integration that you do could be different. A lot of them are luckily the same, but every provider has their own quirks, and they have their own requirements for what you need to do and how you need to transfer the data between the two systems. So we found that Spring integration actually met the bulk of our integration needs for what we needed to do with external providers right out of the box. There was stuff for HTTP, for file transfers, for FTP transfers. It tied in nicely with the batch processing. And we also used RabbitMQ, so that integration point was very nicely woven together. We also had some dynamic workflows that we needed to support in our system. And basically, the way that Spring integration takes the message passing paradigm allowed us to think about these things in isolation and have build components that are very decoupled, but they're also very cohesive, and they do exactly one thing, and they do that thing correctly. And by using a message passing paradigm, we actually were able to focus on building the correct things and actually build our system out by adding to it instead of building our system out by making a lot of changes in a lot of different places. We could actually just create a new component that is very cohesive and does one thing well, change a little bit of configuration in one place, and then we can enhance our system by adding to it. And we found that overall reduced the cyclomatic complexity of the system, because it's just a configuration, and the routing is sort of inverted and helps with that. The messaging patterns actually simplify integrations, is what we found, because as an example, I don't know how many of you guys have had this happen to you, but when you're working with an external provider, what often happens is that your SE team has to get together with their SE team, and they have to work out the logistics of getting the two servers to talk to each other, and you find yourself waiting a lot and waiting on those things to happen. What's nice about Spring integration and the way that it's created its abstractions is that you can very easily stub those things out as messages, and you can have a stand-in that you can actually put into your configuration. You can build out the rest of the system. You can build out what's available to you and see how it actually works in your system, and then as those other parties get together and work out the details that they need to, you can actually just plug that right in and work to the specs, and it worked for us very nicely that way. The other thing, again, forcing you to think about the individual pieces in isolation that you're trying to build, forcing you to figure out what components you actually need to have this integration be successful, will help you make more cohesive components, and it will also force you to think about what is the essential piece of this component and what is it doing, which in turn helps you build radically more simpler things as opposed to trying to build a huge class and getting the integration in a single spot. We also found that just building these things this way with Spring integration actually helped us to reuse things in a lot of places, and that was again due to the cohesive nature of what we came up with. So that's sort of some of the why of why we chose these technologies, and I'm going to give it back to Ellery again, and he's going to dig into actually some of the specifics of what we did to extend these things.
Thank you, Jack. Now, we've done a lot when it comes to building out the framework that we need, and unfortunately, we only have enough time to dig into a few specifics. So what we've chosen to focus on is we've talked a lot about sort of the persistence and the writing of data so far. So we're going to go over two sides of that coin. From a Grails perspective, I'm going to talk about how we've used the hooks that framework provides to effectively build our own form submission API, and then I'll pass it back to Jack to explain how taking that form data into our model layer and then using Spring integration, we've actually built out the persistence piece underneath that exactly the way we want it to. So the form submission API. So when we got into this, we've had a lot of experience using Grails already, and we've encountered problems in past projects when we've had these types of write-heavy issues, when we have people submitting forms all over the place, lots of communication with the database, lots of things changing all the time, and we identified a number of problems that we had with dealing with form submission in the past, and so we wanted to, for CRM, engineer a framework for an API for dealing with form submissions in a unified manner that we could just build on top of and no longer have to worry about it. So that's what we did. The main problems that we were attempting to solve when we were building out this API are, there's three of them in particular. The first is a data binding problem. Since I mentioned we're not using GORM, we couldn't therefore make use of the standard Grails data binding to do all of the form backing, form submission mapping to our domain classes. So we needed a way to do that for any arbitrary model class. And as we've also touched upon, we are dealing with, in many cases, classes that are not even in our project, but we're inheriting from a Java library that one of the other DDC platform tools might expose that we depend upon. So we need to be able to effectively bind data into anything so that we could most easily make use of all of that. Secondly, we have a lot, so since we're dealing with Mongo, we have a lot of documents, and it turns out that in those documents we have a lot of collections. For example, a contact or a customer, car buyer, whatever you wish to call it, has a lot of contact information. You have many email addresses, many phone numbers, and so on. And it turns out that when you're trying to, in a single form submission, bind all of the details that you might want a sales agent to enter on a single customer form, it involves those collections and modifying those collections as part of your form submission. Turns out this is really annoying if you've ever had to try to do this, to account for all of the possibilities where things can go wrong. Man, it's a huge pain. And so we wanted to make certain we had a way to deal with this, since this was going to be happening all the time, all over the place. And then finally, this is somewhat of an aesthetic concern, but also one that we've seen lead to some technical debt in the past, where in the standard Grails paradigm, you have to submit and to show and then process a single form, you oftentimes need multiple controller actions to first render the form and then have a different controller action that you submit your data to and handle any validation errors and so on. And we wanted to really consolidate that so that we don't have to, copy and paste, heaven forbid, or just, maybe just even obfuscate the code by extracting things into a place they don't really need to be, because you're really dealing with a single form. So we wanted something that would do this. So those are the very brief, high-level problems that prompted this. Here is the result. So this is the end form submission API in a programmatic form. I'll just walk you through this very briefly and then dig into what's actually happening here. For those familiar with the Spring Webflow, you'll clearly see some inspiration here as we started with that in mind, and it wasn't quite up to all the tasks we were trying to do, so we ended up learning from it and then building it out to meet our own needs. So what we see here is this is just, for example, a book controller. The create action, so this is a form where we want our users to be able to create books. We specify that we want to do our data binding, our form backing, into a book domain class, which just needs to be any sort of class that embraces a Java Bean convention, such as any Groovy class really, which we specify with the form backing object annotation. Inside of the action, we have a DSL, the OnSubmit DSL, which controls the flow of the form depending on what type of request we have. If it's not a submission, we skip all of it and go straight to the else show form closure, create our backing object, initialize it in what's called the form scope, which I'll talk about shortly, and then render the initial form to the user. But if it is a form submission, we have a whole DSL for processing through these changed closures exactly what each step needs to do and taking the appropriate actions depending on if it was a successful form submission or if there were errors, redisplaying the form and letting the user correct them. So this is the form submission API. So the first piece of that is the form backing object annotation. Now, I love Grails, but I also really do like annotations for specifying in code when you're trying to do something that would otherwise be magical. And so the form backing object annotation was what we used to embed the knowledge right into the controller action of what we want the data binding to do. That's all it is. It just specifies a class that you're performing data binding into. How did we put this together? The annotation is read via reflection, and in standard Grails controller action filters, we check the controller action that the form is getting submitted to, or excuse me, the request is submitting to, and extract the class from this annotation to instantiate using an extension of a Spring data binder to bind that form data into. And we do all of this, again, at the time the request happens, and so it can be any object, not just any of our specific model classes. And by using the Grails plugin do with dynamic methods closure, we do some meta programming to further enhance all classes that are specified as form backing objects. We add these dynamic get errors, set errors, and has errors methods so that any class that we specify as a form backing object using this API gets these methods, and we can put our validation errors onto an instance of that class in the same way that standard Grails developers are used to with the Grails domain classes. So this actually ties directly into the Grails error handling tag libraries. So, tags. So if we put validation errors on any one of these custom form backing objects, our UI developers can make use of the framework features to deal with these things in the same way they're used to with standard domain objects. So that's the form backing object. So next is the form scope. What is a form scope? Well, that'll take a little bit of lead up. So let me describe in more detail what problem this is solving. So I mentioned before modifying collections, huge pain. Well, that is exactly what the form scope was designed to overcome. If we're trying to take a list of something and after submitting a form, we may want to have added new items to it. We may have wanted to modify items in it. We might want to remove some, or we may want to do some combination of all those operations all through a single form submission. This is challenging because form submission is inherently stateless. You're dealing with a single request that you submit to the server, which has all of the parameters that basically make up your form submission. And unfortunately, when you're doing things that modify a collection, you're usually adding or subtracting from an index. So you have a named parameter with an index indicating which item in your list. Like out of my 5 phone numbers, I might be wanting to remove the 3rd one or add a 5th one. The only way we have to identify that is usually through the index that's in the parameter name that we can use for the Spring data binding. And unfortunately, when you're dealing with just one submission, if they added and then removed and then added and then removed, those indexes at the end are going to look the same as, if you add a new item and remove it, or remove an item and then add it, that'll look the same as just updating one item. And so this oftentimes isn't a problem, but I will tell you from experience that there have become many times where you really do care that you're adding versus removing, especially if you're dealing with a more traditional GORM-backed setting where adding and removing items might actually be changing things in different MySQL tables. It's very important to do right. But to even get that working, you have to write a whole lot of UI logic in your JavaScript layer to manage which items are being shown to the user. Oh, they hit remove, so I need to hide the markup for that one item. And oh, they hit add, so I need to figure out how to generate the markup with all of the right hidden fields or non-hidden fields that match all of the right parameters. It's just hugely complicated and very easy to get wrong. However, if you do all of that, everything still goes to heck in a handbasket once you start trying to submit the form and you encounter validation errors. Because at that point, the traditional way of dealing with it is to redisplay the form to the user with all of the validation errors present so that they can make the appropriate steps, fix it, resubmit it. However, when you're dealing with these collections, reconstructing the state of the collection and the object in general so that you can display the form is hugely complicated, especially if you didn't actually persist any of that form submission to the database, especially if this is happening over multiple requests, over repeated submission attempts. It's very, very difficult to do this correctly. So we wanted a way. We wanted to do this, and we wanted to do it right with a minimum amount of headache and hassle for the UI. And the answer that we came up with was using a form scope. And so a form scope, in our parlance, is purely, it's simply a session-scoped map where we're able to store information about a single form, not a single type of form, but a very specific form in the session, linking it to that form using a unique token, basically a UUID. And we use that map to store any information necessary regarding the state of the form backing object or any other things that might happen with your conversation with the form. That state is actually then modified, or modifiable, I should say, by making asynchronous AJAX calls that can do things such as say, I want to remove this item, or I want to add a new one. And then it allows the server to handle what exactly that means. So you can say, I want to add a new phone number to this list of phone numbers in my form backing object. The server can say, that's great. It takes care of modifying the data structure that you're going to be binding your form data into, and then actually render the markup that includes all of the appropriate field names with the appropriate indexes after the operation, and send that right back to the view, so it doesn't have to handle any of it. Because of this, you can perform advanced state manipulations on your form backing object in your form scope without having to persist anything to the database. So if indeed everything does go pear-shaped, the user can cancel out of it and nothing has been persisted. Yet if it takes them many tries to finally get it right, they can do that. And so you can have this mutable state without really having a database necessary. And then when it comes to dealing with those validation errors I mentioned, rather than try to reconstruct what the state might be, you can just read it right out of the form scope and to serve it up as though that were the data out of the database for an initial page view. So to illustrate what exactly the workflow for doing this might be, if we imagine we're dealing with a form to modify a list of phone numbers. Our initial form, we see that from the database we've got 3 phone numbers. We want to initialize our form scope with those 3 phone numbers as the form backing object. And so that's living in the session linked with a unique token. Then as the user starts using the UI components to add and remove items, it makes asynchronous calls which call out to dynamic controller actions that we actually, with metaprogramming, add to all of our controllers in the UI application to add and remove from that specific form scope by using that token that I mentioned. So we, for example, in the first step here, say we want to remove the phone number at index 1. Well, the server takes care of it, it nulls it out, and tells the UI, okay, I know it's done. You can submit all of your form data, and I will just assume that the item in index 1 has been removed. But now we add another new item. It will just create it, doing whatever instantiation through Spring data binding is necessary, and then render the markup that's necessary to populate that item with all of the appropriate indexes and so forth, and give that back to the browser for display. And then finally, the actual form submission, once all of this collection modification is done, let's say we want to actually also, after we added a new phone number, we also want to update the phone number at index 2, change it around. We can just do that via standard form submission. There's no actual additional logic because we have all of our form inputs matching the state of the form backing object that's being stored on the server. So then it's just a standard form submission, and it goes through the standard data binding and submission process. And if there are any errors, it can be redisplayed and preserve the exact state that we left on and that we thought we were having. How did we actually implement this? Well, we tapped into a lot of features that Grails exposes. So we create the form scope on demand the first time that data is written into it, which can be done either manually or automatically depending on what the needs of the form are. And it's stored in the request at first, and then again linked to the session. So every request has one and only one form scope at any given time. We exposed the token that we linked the scope we created to in the session via a custom extension of the G form tag, and so it's exposed via a hidden form field, and thus is accessible from the front end or on a normal form submission. And when that happens, when we have that special parameter with the unique token, when a new request happens, we use Grails filters to pull out the token from the request parameters and initialize the form scope in the current request based off of what is found in the session based on that token. And then all of this comes together when the plugins do with dynamic methods closure again, which allows us to inject the request's form scope into all of our controllers as a dynamic form property in the same way that any Grails developers out there might be familiar with for the dynamic params property or request property. We expose the form scope in the same way and allow manipulation inside of your controllers without any additional work. And then all of the add remove AJAX actions that I talked about are also, as I mentioned, with metaprogramming added to all of the controller actions so that we can have one unified API for doing all of our collection manipulation without needing to have to copy and paste another add and remove action into each controller as necessary. So finally, the last piece of the API that I'll talk about is the OnSubmit DSL. To refresh your memory, this is what it looks like. This is inside of a controller action where you're able to define effectively the flow for handling a single form submission, or excuse me, the submission of a single form over one or many requests. It starts with an OnSubmit closure, which will get invoked if you have a form submission. It will then take the return value from this closure and check it to see if there were any validation or binding errors. And if there were, it will go right into the handle errors closure. Otherwise, it will call the if valid closure, which means you've had a successful form submission and can do whatever redirection or additional processing is necessary. So in this case, for example, if we try to create the book and there were errors, we can skip right to the handle errors and redisplay it so they can fix them. Otherwise, we assume it was successful. We can set something in our flash scope and then chain them to a different controller action, in this case the show page for that new book we've created. And then finally, you can just use the else show form closure to do whatever initial setup is required to populate your form scope or form backing object, possibly from the database or not, and then render it to the user. This DSL follows this general workflow, which I just described, but it's very simple. It's just we check if it's a form submission, and if it isn't, we skip right to the else show form closure. If it is, we execute OnSubmit closure by passing in the form backing object as the first argument. If we assume then that's returned from that first closure, and we check the return value to see if there were errors. If so, call the handle errors handle errors closure. If not, we process the if valid closure. And so I mean it's pretty simple and allows us to encapsulate all of the standard actions that go along with form submission, regardless of what form you might have to deal with. Those we have found to be the standard pieces that you need to write your code around. So how did we actually put this into our project? Well, as I said, those are just chain closures, and we're injecting the DSL, again, using the Grails hooks to enhance the controllers by putting that DSL into it using the do with dynamic methods closure in the Grails plugin API. And via filters, we handle all of the pre-processing per request to determine what state of the DSL needs to be executed, and then we pass the form backing object that I spoke about earlier into it. And the benefits here are that by making this custom DSL for our needs, we've been able to cut out all of the cruft that we have found in the framework as we've used it before this project to specifically meet the needs that we had. We can create the model just the one time. We don't have to split it out into a bunch of different places, so it can be called from different controller actions. And it nicely integrates the other two pieces I just went over into a single cohesive API that encapsulates everything you need to know about the code that's processing a given form into a single place. So, and it, of course, then ties into the Grails errors handling, as I mentioned before. So before I pass it off to Jack, that's basically, I mean, obviously that's very high level. There will be code explaining that goes into all the specifics of how that happened available. I have to coordinate a few things with the business to clean it up and for public consumption, but that will be hopefully available off the Spring website or off of GitHub. If that's the case, then I will include in the slides the appropriate links that you can use to look at that, since obviously that's too high level to really dig into if you're trying to do something similar, but it will be available to look into later. So that's how we process the data from the user. Oh, sorry, you have a question?
I have a question with the form scope.
Yes.
That was tied with the session, right?
Yes.
So how did you guys have session replication? How did you handle, in case the server dies for some reason?
So the question was, the form scope is stored in the session, so how do we handle it if the session goes away, if it gets killed? And the answer is right now, we don't have any forms that are so terrible that they can't be redone if it goes away. This is the one I mentioned before. We're largely stateless in our applications. This is the one instance where we currently are still relying on a specific application to store that session data. And so we use sticky sessions to make certain that even though we could have an arbitrary number of UI applications running at any given time, that given user is only going to be talking to one of them for the course of their session. But it's a good question, and it's actually an area that we've looked at enhancing in the future so that we can avoid our dependency on that one piece of state. And I'm going to hand it off to Jack to explain how, once we've gotten the data from the user with this form submission API, how do we actually persist that to the database?
All right. So you use your form scope, you hit submit, presumably you want to persist, so what happens next? Well, after that, the data makes its way to our persistence layer. And we didn't actually start out with the intention of actually building our persistence layer with Spring integration. We originally said, okay, we need to have a custom persistence layer because we have all these other concerns and want low-level access to the database. And so we started with some DAO classes and some services around that. And what we found was that we were ending up with 90% of the stuff doing the same thing, but there were a lot of classes that were simply serving as marker classes. And we were basically creating classes in the code to just serve as markers and really for no other purpose, right? So you have to create these classes, and it's like we're doing configuration by creating classes. So that got a little bit annoying. We had to specialize these classes in a few places, and doing that was a little bit tough with the original structure that we had, because we found that we were making we had a hierarchy for the persistence, and we found that we were making changes in more places than we would have liked when we had to add some specific custom functionality for a lead a lead persistence or for a contact persistence or any one of these model classes that we were trying to stick in the database. So we had a little too much coupling, and it was a pain to work with that structure. So then we took a step back and we said, if we treat our persistence layer as an integration with the database, we could probably actually make use of Spring integration to do this for us, and we can get some of these things that we're looking to do out of it. And so that's what we did. That's where we ended up going. And you might think that if you're using messaging for your persistence layer, that's going to be weird and foreign looking to the programmers who are writing the business logic and the services making use of it. But thanks to Spring integration, we actually we're able to maintain an API that looks like a regular sort of persistence API. So the API that we're going for with this CRUD persistence service that we have basically has your standard operations: create, read, update. We can find by query. We can extend this, and for let's say we have an opportunity or a contact, we can add extra finders in here as we need to. The thing to note is that it looks very straightforward and easy to work with in the service layer, and what we're passing in are options and queries, and the query objects are actually Spring data queries. So we're making use of that, injecting it into we keep those in libraries, we pass those in as parameters, and then that gets picked up by the persistence layer. The message gets created, and we actually use those query objects directly against Mongo. Likewise, the options are some well-known options that we allow any persistence action to make use of, and we keep those organized in libraries as well, and those get just transformed into message headers as the CRUD service sort of hands things off to a gateway. So at the highest level, the way that the CRUD is modeled is as an integration pipeline of these chains. So you have that CRUD service, and that's basically a gateway that will create a message and then dump it onto this channel. And then that message will travel through different sub-chains within the main CRUD chain, and that's where we go through a variety of steps that basically get the message to the database. And so this picture right here represents the 90% that I was talking about. This is what always happens when we're doing persistence. It's largely the same, and we have some hooks provided to specialize. But this is that 90%. The nice piece is, so I've modeled this using the enterprise integration pattern pictures and the standard sort of using that vocabulary. And as it turns out, this picture is pretty straightforward to look at if you're familiar with that vocabulary, and additionally, the configuration is likewise just as simple, right? So you have an outer chain and then a bunch of gateways that everything just flows through, and it's very nice to be able to use that vocabulary that it gives you and have this configuration look exactly like the picture that you were trying to draw to describe it. So let's dig a little bit in and talk about the first step, which is the enrichment channel. And so the enrichment chain is actually where we handle our cross-cutting concerns in getting the message from the service layer through the data layer and to the database. So what we do here is first we actually set up the action that we're going to be doing. So in this case, let's say it's a contact update, right? So you have this message in there, and then we say, okay, I see it's a contact. We can put on the appropriate headers. We know it's going to be an update operation. And then we have some hooks. Now, we're not always using these hooks, but we have other gateways that people who need something beyond the normal 90% can tap into and basically add their extra specific functionality on top of this. And this is specialization for the purpose of enriching this message. So after that, we actually pass through to our security headers, make sure that we're doing some bookkeeping as to who the user is that's actually writing this data into the database. We can have some audit information, some headers, basically keep a context for what's going on with this write and who's doing it. In the case of a contact update, there's no need to do any paging But our reads also go through this enrichment chain, and if we're doing a find by query, then this would be the place where the appropriate headers would be created and extracted from the request and added to the message to say, get me page 3 or get me page 5, and here's my sort order. And then additionally, I talked about multi-tenancy, and so we also have a step in here where we take the message header and make sure that things are in line with what actual dealership it's going to, what stores can and cannot have access to this specific right, and the particulars of what's actually being persisted here. And so what we end up with out of this chain is a message that has a lot of the headers for cross-cutting concerns set up so that we can pass it through to the validation chain. And so the validation chain applies to writes only, so we'll filter those out, and then we will select the validation groups. So we're using an enhanced version of the JSR 303 implementation, where in normal JSR 303 you can make your validation groups for a single class. We actually have a custom DSL that we've created where we can mix these up and actually have different validations per instance instead of per class. We can select those validation groups here, and this is what allows us to do a lot of customization and have different rules applied to different dealerships if we need to. The thing to note about having the validation here in persistence at all is that we talked about using MongoDB as our persistence layer, and everyone knows that that's a schemaless database. Well, if all that means is that the database just doesn't enforce a schema, so if you want your code to work, we actually have to do some validation here to make sure that the message is structured correctly, that all the appropriate fields that we want on there are filled out, and that the data integrity is retained as this message is being written to the database. So again, there's another hook, and then we'll send that off to the validation service. And since this is a Spring integration chain where everything is wired up directly on the same VM, if the validation goes through, then the message will simply pass forward. But if there are errors in any of the validation, then the message will simply get kicked back up through the direct channels, and it'll get handled by the original caller because everything's happening in one thread and it's all the same logical transaction. So that works very nicely. So assuming we've passed through validation, we actually get to the database, or we're close to getting to the right. So what we do first in this database chain is actually select the data source. And right now, that means I'm doing a contact persist. So I'm going to select the contact DAO. Actually extracting the data source selection to the first part of this to this chain gives us a lot more power than that, because what we have here is the flexibility to actually select a data source. So even though we're just selecting the contact collection from this specific MongoDB, we actually could say give me the secondary contact collection, or give me the contact collection from another database, or if we have another purpose, we can still go through this database chain and select a data source from somewhere completely different. It's the fact that we've extracted data source selection to the front of this chain that lets it get routed and flow through the rest of the system, and it's a nice abstraction for actually extending this. So it's very powerful that it's in that spot. You'll notice we have some hooks there. There's some final routing that happens, and then it actually goes to to a service activator that will take that data source that was attached on a header and then perform the operation with the database. In this case, it'll do the update. We have some specialized actions on top of the regular CRUD, and then again it'll get fed back into a hook. So here we have basically a successful database is written. Taking a look at what we're doing here, right? Here's the chain. We have a DAO selector service. Thing to note is that the routing expression is simply a convention that we adopted. There's no, we did not have the need to write something heavyweight in order to route the the message to the appropriate service activator in the end. So what we came up with was a convention where we could just use the Spring expression language and say, okay, we're just going to take the action that came in from the enrichment step, add the word channel to it, and we'll have a bunch of those service activators there, and that has held up for a long time without needing to write a class. We can replace that at any point if we need to get more sophisticated, but it's been simple and it's worked really well. So a little bit of configuration on the Spring side can go a long way. Again, here we have these service activators where it dumps out to, and basically to add more functionality, we just create another service activator and make sure the routing checks out, and we have a specialization that we can add. So that's actually very nice and very easy to configure. I mentioned that we have a cleanup chain, and that cleanup chain actually represents a refactor that we did. So what happened is that database chain originally was always just doing the writes to the database right then and there. And what we found was that it was actually our application logic that was setting the most traps for us. So we would have these requests where you would have to maybe persist the contact, and then the lead data that was accompanied with it to another collection, and basically we write our documents across multiple collections. And we found that the most traps were in the business logic. So we said, you know what, let's change up our database flow, keeping the same chain, but just replacing one class in there. We said, let's change that up so that instead of always directly just writing to the database, we're going to build up a transactional context in the background, and then once we've cleared all the traps and gotten past the business logic, and we know that we want to persist these things together, we'll actually make an attempt to persist that thing together at the end. And so that's what this cleanup chain represents, is we do a little extra bookkeeping once you've cleared the database chain, and then we actually do the persistence operation so that we don't have transactional guarantees for Mongo, but we at least have an attempt and a much smaller window of failure when we're trying to just write all of our stuff in sequence to the database. And so that's what this final chain represents. Another area where we're making good use of Spring integration is in queuing up commands. So originally, off of the database chain, we used to just have a pub sub channel hanging out at the end, and you can hook in a bunch of service activators, and basically those would execute some commands that needed to happen asynchronously and in the background. Well, we found that there were two things with that. One was that this work didn't need to happen immediately, so we could gain some benefits by trading off the locality for the benefit of allowing any of our services applications to actually process any one of these commands. So it doesn't always have to be the one that the command originated from. So that was something that if we traded one for the other, we could actually gain some performance by simply saying any service can process any command. And the other thing that we wanted was to have a way to ensure that these commands will always get processed, or have a reasonable guarantee of that. So what we did is we took that workflow that started off as a pub sub channel and then basically hooked RabbitMQ into it using channel adapters as opposed to just direct channels. And the way that this works is that we queue up a command message, and then that will get published to the RabbitMQ exchange, and then that'll go in for its processing. Now, assuming that the processing is good, it'll just terminate into whatever channel is at the end of those service activators. But if an exception is thrown, and if that exception comes about due to a network error or any number of errors that we think we can reasonably recover from, what we'll do is we'll queue that message up on this failure channel, and that'll get republished to the Rabbit broker, and it'll actually end up on this other failure channel. And right now we're giving those channels equal priority, but we could add a delayer in there or do some sort of QoS. We don't have the need for that. So what happens after that is we'll basically go through the same exact processing as before. Hopefully this time the network condition will have cleared up. But if we fail to process and it's not one of the exceptions that we think we can reasonably retry, or if we go past the retry threshold, then we'll actually just dump that on a dead letter queue, and then that will notify us and we'll disposition the messages and figure out what's going on, if there's an actual programmer error or if there was something else happening there. And so we're using Spring Retry to do some of the talking with Rabbit, and just basically Spring integration to make use of that. So the final piece that we're doing is for lead intake. We're using Spring integration. And the thing to really note here is that we have the same pipeline, right? But for third-party leads and leads from other parts of the platform, we have to do a little pre-processing that we don't have to do when you just enter the leads manually through the CRM system itself. And the nice part to note here is that everything sort of goes through the same flow, and it all ends up in the CRUD channel. So everything is nicely tied together that way. So that's some of how we're using Spring integration. With that in mind, we actually learned some lessons in working with it. So we've been working with it for a couple years now. I've been using it personally since about version 1.3. And the first thing I noticed is that the debugging has much improved. If you learn to use your message history and your wiretaps and your logging channel adapters, you can get a lot out of the debugging. But it's still confusing because this is a message-oriented paradigm. So you're never going to get away from a complete understanding if you go in with the mindset of, I'm just going to try and debug this like regular code. The other thing on top of debugging is that you should always keep your flows simple and make sure you test these flows. So there's a Spring integration test library that you can use, and that has some Hamcrest matchers and some things that actually makes it easier to test your payloads. And actually there's a book called Spring Integration in Action, where the last chapter is dedicated to testing, and that chapter is really good in giving you some tips for how to debug debug and test your Spring integration flows. The other thing is that just because it's easy to do in Spring integration doesn't mean you should do it. So by that I mean you have to understand your flows. So if you take a look at our persistence layer, I wouldn't recommend adding something in there that would make a web service call, right? Because you may be servicing a request that's coming from a user, and since it's happening synchronously there, you'd be stalling out that request if it took a long time. So the interfaces are all the same. It's very uniform. It's a very uniform system, but you have to be careful and understand what it is that you're working with so that you don't make performance problems for yourself. And also you should look to yourself when you encounter performance problems, because the framework is very solid. But it's easy to through carelessness make some mistakes and suffer some performance issues, but that can all be worked through. Anyway, Ellery.
Thank you, Jack. So I want to move on very quickly through some of the lessons we've learned using Grails and the way we've talked, and then we'll make time at the end for whatever questions you guys might have. So first and foremost, I wanted to mention, with a caveat, that we are using, we've been developing this for several years now. So most of our development has happened on the 1.3x series of Grails, and obviously you're at the conference here hearing about a whole lot of new stuff that may sort of obviate some of these issues, but it is important to just at least draw attention to them so that you know at least what we've found to be troubling. I'll just say that dependency management, when we have a complex project using Grails, is very, very, very difficult. We spent a lot of time on it, but thankfully that's one area I know that has undergone a lot of improvement since we started. We continue to see that there is a large amount of overhead when it comes to starting, stopping, and building our applications. It takes us about, with our Hudson job, to build our release, about 15 minutes to build all of the plugins, build all of the applications, and deploy it. And then starting locally, when you have to do a full rebuild, especially if you've pulled in the latest code from the version control repository and you need to do a full clean, it's usually the kind of thing where you do that, you set it to build in the background, you go grab a cup of coffee. So that is, it's been challenging from time to time. We're using plugins, as I've talked about already, and we're using them for development speed as inline plugins, which is a very useful feature of Grails, that you don't have to just deploy your plugin off to a Maven repository and pull it in every time you change the code. You can just run it inline. It will detect it for hot reloading everything else, but it really does lead to some other issues, such as the whole "it works on my machine" that you'll hear a developer say, and another developer has problems, and just working through that can be more challenging because of it. And then it just does contribute to more of the build process issues that I discussed, including the dependencies. So dynamic typing. This is something, dynamic typing, metaprogramming. It's really there's a lot of people who feel strongly on both for and against it. And so, we've obviously erred on the side of we like it more than we dislike it. We can do some really neat things, which I showed you before, but it is, from time to time, a double-edged sword. A lot of people do not like dynamic typing, especially of concern from an enterprise project when you might need to have, a team of 20 people working on it. Know that we have some people who really, really do not like dynamic typing and everything that goes along with it. The plus of using Grails and Spring is, they can still write Java and contribute, but something to be aware of. And also, though, with metaprogramming, the DSLs let you do really, really cool stuff like we saw, but sometimes that just becomes magical to people who don't know the underpinnings of what's going on, and it's therefore harder for new people to get up to speed on the framework. And leads to people who don't really know where things are happening and can't hunt through the code to just say, oh, well, so-and-so made that, so ask him if there's a problem. So something to keep in mind there. And then like with Spring integration, Grails is really great for productivity. It offers a lot of framework hooks, but it does sometimes make it too easy. And we've seen a number of times where, because it's so simple for anyone, UI developer, backend developer, to just do stuff, inject a dependency here, put a service in a tag library, call a template in the wrong place. It allows people to do stuff without communicating necessarily with the people who are specialists in that area, so that you can end up with performance bottlenecks or reuse of code that was not intended to be reused. And that can lead to more technical debt down the line. So just something to keep in mind. Much like with Spring integration, it's all about developer discipline and communication more than anything. But it is something to be aware of. And then finally, I'll just say that IDE support for Grails applications has come a long way, but we still struggle with this every day. We have a very complex and large series of Grails applications, and trying to get them to work in the IDE, whether it's Eclipse, STS, or IDEA, they've all fallen down one way or another. And this does become a problem when you're trying to fire up a debugger and figure out what's going on with a running application, or if you're even just wanting to run your unit tests inside of your IDE so you don't have to wait for the whole 10 minutes it might take to run your entire test suite every time you want to check something. It's something to be aware of. But really, the final thoughts here are still very positive. We're very happy with the choices we've made with these technologies to address the problems and challenges that we've talked about. They give us a whole bunch of features with the support for the extensibility that we were after, and they've met all of the needs we've had. It's a platform that has served us well and can grow to any future needs we might come across. And the stumbling blocks are definitely more than outweighed by the value we've seen. And we've done a heck of a lot more than we've had time to talk about here. Just as an example, Jack mentioned we extended the form validation JSR 303 spec to allow mix-ins instead of annotating the classes itself, and putting validation constraints on nested properties to fit with the Mongo document paradigm. We've extended Yammer metrics to build a plugin to get extensive reporting piped to Graphite for a per controller action basis. We've published logs to Graylog using the controller action and filters to enhance the MDC to pass along useful things for our log messages, such as controller action, user, all the rest. That's made very, very easy to monitor what's happening in our servers in real time and dig into it as we go. But we don't have time to get into all the specifics on that. So at this point, if anyone has any questions, we'd love to field them. Yes, sir. Turn on your mic. What did we use for rendering on our web front end? Yes. That's the question. Well, our front end is pure. I mean, it's standard Grails. One of the reasons we separated it out into the. Not really. No, we just did standard GSPs, tag libraries, controller actions, and that paradigm has actually served all our needs. We've built on top of that, so we've got a lot of customized extensions to that, but it's at its heart. We're just using the standard Grails UI offering because we found it to be so powerful.
Does that mean using templates or having
So the question was, does that mean we're using the GSPs or are we doing the rendering in the client via JavaScript? The answer is primarily we're just using the GSPs and we're passing markup back to the view. But there have been cases where we've been able to, for a specific feature, use like knockout or use other technologies that involve rendering things dynamically. It's offered us the flexibility to pick the right approach for our needs. So we have some of all of that. But predominantly we've found that we've just been rendering the GSPs and then giving it to the front end. Yes, you, sir.
So you said you did all these custom plugins or whatever for a lot of the auditing and monitoring.
Yes.
Why not choose some of the existing Grails plugins that are out there, like the Melody or the App Info or any of those? Or are you using those as well?
So the question was, why don't we use a lot of existing Grails plugins for some of the monitoring that I was discussing? And I will say that in many cases, we've actually broader than just for this one purpose. We found that Grails plugins in the public repository are a great starting point because they give you a lot of insight in how you would do these sorts of concerns in a Grails application. But out of the box, they have oftentimes not lived up to the complexity of the projects that we have had. And so I can't speak to those specific plugins that you mentioned, but we have for all of these cases, we haven't just sort of gone off and started building. We've always tried to find something that's out there before we say, okay, well, this isn't up to our needs, so let's customize or build it ourselves. So it's a terrific question, and we can talk more about those specifics afterwards. But in general, I will say that when we've had to go it on our own, it's because the specific plugins just haven't given us all of the features for all of the situations that our application structure has merited.
And in the cases where we start with something like Yammer metrics, we're actually looking to contribute that back. We have a DealerComm Spring source repository, and we're looking to clean up some of that stuff and actually put it back into that repository so other people can use it.
I was wondering what you did for authentication, but if that's a long answer,
It is, and then there's actually a man in the crowd who did most of that for our entire platform, who I'm sure you can chat with after.
He's right there.
He's right over there. You can chat with after the talk because it's its own whole multiple talks, I'm sure. Any other questions? You, sir.
If you have, when you any conversations your team might have had going from Grails 1.3 to 2, what hurdles did you discover that would make it difficult?
So the question is, if you've had the conversation of going from the 1.3 series to the 2.0 series for Grails, what are the complications? Well, I look forward to finding that out, since that's actually the next thing on my plate when I get back from this conference. We have, as a platform, moved towards Grails 2, and we're actually holding things up because, as I mentioned, we're in CRM, we're doing a lot of low-level framework features that require a bit more in the way of pain when it comes to making the version switch. And this is, we know from experience, a point of concern. I mean, it's going to be ideally switching to a new version of the framework is as simple as changing a version number, building with a different library, and then you're done. We know from experience, we've tried it, that is not true for us. And
well,
that's
we're changing major versions, right? So
yeah.
the APIs have changed, and we've made use of those APIs, so we're going to have to make up for that. Yes?
Did you run into anything that was particularly challenging because of Grails' big conventional configuration?
Question was, did we come up with any challenges specifically related to Grails convention over configuration? And I would say that honestly, not really. There's the dependency management issues, but that has less to do with the convention and more to do with underlying problems in the technologies they chose in that series to use. Because we found that having that convention actually makes it, even if the code doesn't have all of the config, it's made it just super easy to know, more so than even if you have it enumerated in a config file. A new developer wants to know where to go, he has the whole resources surrounding Grails that he can tap into to figure out where should I look to do, how should I put this in there. So no, I would say that we found that even though we're again using Grails kind of as core Spring, having the conventions over configuration has really helped us out tremendously for productivity, for reducing technical debt, and just overall has been very successful.
With the big exception, of course, being GORM, right? So its convention didn't fit our needs, so we just sort of switched off.
Yeah. You, sir.
You were talking about, you touched briefly
Yes.
Did you guys use just one standard package of testing tools, or what did you guys do there?
So the question is, what did we do for testing? Did we use a standard package of testing tools? And that's actually, it's a whole, well, several other talks. I encourage everyone out there to, if you're interested in unit testing or functional testing, to listen to Luke Daly is giving a number of talks today on the various things we're actually using in our project. Spock as a general unit testing framework, using Jeb for functional testing. And to answer the specifics of your question, no, we're not using just one thing. We're trying to, we've built out a lot of testing around specific goals. Like if this feature merits a unit test, write a unit test. And if you're more comfortable writing a JUnit test, or go for it. But if if you like using Spock, write a Spock test. And it's been so far pretty successful, since all of the hooks that are available to the framework doesn't really force you down one of those paths. Again, it's been more that we've tried to pick the right tool for the right job. So when it's come up, we noticed that sometimes, especially with this persistence layer, there's some stuff that can be unit tested, but a lot of it, there's so many things happening that it really merits an integration test in order to do properly. I will say, however, that by and large, we're not making any use of the Grails integration test feature. So that's something that, related to your question, I have found to be very brittle. It does not properly mock out the environment for you, and it's very slow, so people don't like running them. So when it's come to integration tests, we've actually used an extension to Jeb, which is for functional tests, to actually to stand up a fully running instance of both of our applications and run our tests against them in an actual integration environment, instead of using the Grails integration tests. You, sir.
I'd be interested to know what kind of distribution, what kind of scaling you use. I mean, given like the data portion of it.
Yep.
Do you do horizontal scaling for each? You have two main pieces, and then you just horizontally scale each, or do you do some sort of a vertical scaling with, components, subcomponents within?
So the question is, how do we approach scaling? Do we just stick with horizontal scaling of the applications, or do we have some vertical scaling strategies? Primarily, it's been just horizontal. When necessary, being able to spin up arbitrary new instances of our services app and put them behind a load balancer that all of our UI applications communicate with, means that we can effectively deal with whatever load might be necessary without having to worry about anything except just new instances of the application. But at the same time, we can spin up new instances that aren't connected to that load balancer to make use of things like the command queue that Jack talked about, to do batch processing in the background without actually impacting any of the users who might be relying on getting a request back synchronously. So it's mostly, we designed this to be horizontally scalable first and foremost. So I think, does that answer the question?
Yeah.
All right. Any other questions? We've got about 2.5 minutes. All right. Done early. Well, thank you so much for attending our talk.